All right, so hello everyone. Today is May 1st, 2019. This is the bi-weekly Kubernetes cloud provider meeting. Reminder again that if you're here, please add your name to the attending list on the agenda. And we have a pretty short agenda today, so if you want to add any last minute items, please feel free to do so. So the first thing I wanted to discuss is the SIG face-to-face session at KubeCon. I'd like to get a sense for who's going to be there. So if you are planning to attend, please add your name in the list there so we can plan accordingly. And also, I'd like to kind of get a feel for what topics people want to discuss during the session. So I put two things down: establishing concrete timelines for when we're going to remove the cloud providers. I know this has been discussed like at pretty much every KubeCon, but I think we've been making a lot of good progress in the last few quarters. So I think we'll be at a better state to actually predict and establish some concrete timelines for this effort. And I also put down driving adoption for out-of-tree cloud providers. So I know a lot of providers have been building, testing, developing their out-of-tree cloud providers. And so it'd be great if we can kind of come up with a strategy as a SIG to figure out, how are we going to drive adoption of these providers going forward. So yeah, feel free to just add more topics onto the agenda, and then we can try to organize something closer to the date and try to prioritize what things we want discussed at the SIG session. All right, cool. So first item on the agenda is by Jonathan discussing physical host labeling KEP. Go for it, Jonathan.
Yeah, hello. So if you haven't seen this KEP, it's part of this whole discussion of topology labels and provider-specific topology labels. But this specific KEP is actually meant to be just sort of a small orthogonal improvement, which is adding one well-defined topology label for a physical machine. The motivation here is that we have a lot of Kubernetes deployments run on VMs, and we may do some spreading of pods among nodes. And those nodes could be running on the same VM host without the cluster admin's knowledge, and so that itself is hurts reliability. So in scheduling, we're working on a new feature for even spreading across failure domains, and this feature will not be specific to any topology. The user has to specify the topology label. But in parallel, we also wanted to push through a new sort of well-defined physical host label so that this topology would be available. I think some of the I've seen a couple different valid points raised. So some people are advocating that providers should be able to add arbitrary labels to nodes. And I think this generally has support from the community, but would be a different effort. And then there's also the case that any cloud provider that's capable of doing VM migration, which I'm pretty sure is true of VMware, the topology label value would be capable of changing at runtime. And so I think that it's probably up to each provider, but like the right thing to do would be to update the label when the VM migrates. But that raises a whole bunch of fun questions for SIG scheduling. So yeah, I guess if people had questions or concerns they wanted to discuss about this, now we've already missed the deadline for 115 for this specific proposal, so it's now going to be a 116 proposal. So we'll have a lot of time to talk about it. But if anyone wants to bring anything up about it today, I'm here to talk about it.
So I guess the hearing echo. Okay, yeah, thanks. So yeah, I guess like the first question which has come up in the mailing list is how do we, like what criteria do we use to actually determine if a topology label should be in like Kubernetes namespaced or it should be, provider namespaced, right? And so um, I'd like to go with the rule of if a topology label is as common as what we have today, which is zones and regions. So like if we can say like there are as many providers that expose the physical host IDs or whatever of a Kubernetes node as commonly as zones and regions, then it would warrant a zones region. It would warrant a Kubernetes namespace label. That's just my personal take on this because like we have to be honest and say that like adding labels and adding more to the current interface we have for cloud providers is definitely adds complexity to what is already sort of a mess, right? And so I think, yeah, so I think we need to gauge that. Like, is physical host common enough to warrant Kubernetes namespace topology label?
So I don't know that I can necessarily answer that question, but I think there's two ways to interpret your criteria, because I guess there was one question of like, is it commonly exposed by cloud providers? And maybe it's not, even though most cloud providers are providing VMs, they're not exposing the ID of the physical host or some kind of unique identifier. But the other question is, I guess maybe like, would they, if there were a standardized way to do so? And so there, I think maybe the sort of the threshold becomes a combination of like, does this concept apply to most cloud providers? And then I guess maybe weighing in the probability that they would actually implement it. And I think the concept is very widely applicable, but I am not able to gauge the willingness of any particular cloud provider.
Yeah, and I'd be hesitant to. Sorry, go ahead, Jago.
I was just going to say, I think it would be useful to talk more in terms of who are the users of such labels. That, like, the scheduler is one such client of those labels. SIG apps likely has some folks who would be very interested. And I think one goal that we need to keep in mind is the portability of workloads across implementations of Kubernetes. And so that's the value we get out of structured labels, is that they just still work when you deploy to a different environment. And the corresponding risk is that we reduce to the least common denominator and fail the ability to take advantage of more powerful features in specific environments. So it seems like this is coming up more and more. We had racks and something similar, I can't remember, in the last cloud provider meeting, but trying to come up with a longer term plan, since we already missed the boat for 115, seems like a useful thing to do in anticipation of 116. And trying to think in terms of who are the users of those labels and what are the use cases might be useful. We're not terribly good at that in this community in general. We're good at writing great code, but we're not always good at thinking through who else is using this and what is the longer term plan. So,
yeah, I agree. And I think Tim was kind of advocating for that in the mailing list. And yeah, I don't think we should assume that, and I'm not saying that you're saying this, but I don't think we should assume that if we support this topology in Kubernetes, then cloud providers will eventually expose that to add value to people running on top of Kubernetes, right? So I think we should, if we find over time that more providers are exposing, physical host IDs up the stack, then maybe we can use that as a common topology label. But I don't think it would make sense to predict that as a possibility without actually, basing it off of real user experiences. That makes sense.
And Jonathan, sorry if I missed this, but can you go back and describe why is it useful to have physical host as a schedulable specific instance?
Sure. So just to clarify, none of these topology labels are planned to be hard-coded into the scheduler. Rather, in SIG scheduling, we're working on a new pod spreading feature where you specify that I want my deployment to be evenly spread across racks or across zones or across physical hosts. And so this is more like a mechanism to prevent too many replicas from landing on the same physical host.
Okay, that's helpful. They're not a hard-coded physical host that would be sort of counter to the whole intention of being able to replace something that dies along the way. It's more in terms of articulating the customer's intent to reduce blast radius or avoid outages. Yeah.
Yeah, and we're reusing the concept of topology key, which is something that was created for our affinity rules. And topology key, you specify what is the label that identifies the topology that we care about for the purposes of this scheduling decision. So you can say my topology key is, zone, or I guess you could even specify kubernetes.io/hostname as your topology key and say, I want these to be evenly spread across my nodes. But like the physical host is specifically because those nodes might share a physical host.
Do we expect users will try to co-schedule pods onto the same node for lower latency, for example?
I'm not aware of that use case. I mean, I don't know that you're guaranteed better performance between VMs on the same host. That would be very provider specific, I imagine. But in theory, I guess it could help, but there might be some better abstraction for it.
Yeah, Steve, go for it.
Yeah, I would clearly expect people to do it. I mean, if we're going to support essentially anti-affinity, then supporting the reverse of affinity, it makes sense for some use cases too. I mean, just trying to schedule things close together to avoid latency penalties, because once you cross failure domains with much modern technology, there are latency penalties for crossing those boundaries. So I'd expect people would want that. One thing I'd throw out there as kind of a means to get around hard identifications of specific hardware that aren't portable is something that already has precedent in storage, which is the storage classes, where the pods themselves put down preferences essentially that map to a class. And the class is a second level of abstraction that an admin then would in turn map to very specific backing store providers. And it means that the pod specs themselves and things based on pods, replica sets, etc., are indeed portable. But as you get closer to an actual deployment in a physically unique cloud, there is an admin step that's necessary to map them to get desired outcomes, but it's constrained and it's generally going to be one time only, and you do it and you're done. And maybe we have an opportunity to use that kind of model here, where the actual thing that's standardized and popped up is general classes that still don't map to specific cloud provider specific hardware or characteristics, but map to a secondary tier that would be put in place by an admin when you land in a particular cloud.
It's like the EI, the cloud,
Yeah, I haven't thought about, it just came to me. I don't know what it would be called, but essentially storage classes are like that, right? I mean, they, at the higher level, the pods simply map to the storage classes, and those are very portable. If you know what you're doing, you define your classes with labels corresponding to desired outcomes. Like I have this class of high performance storage and this other class of cheap storage, for example. And no matter what cloud you'd land in, there's always likely to be a concept of high performance versus cheap. But what that really ends up being would be cloud specific. And maybe we can come across with something similar to that for this idea for a cloud provider support for scheduling that doesn't break portability.
Yeah, and I think we have CSI and CNI. I think what you're suggesting is something like CPI or
is the P for provider.
Yeah, cloud does either C provider interface or cloud provider interface, either way.
But yeah, thank you, Stephen. It sounds like, I mean, just to, if we're talking about classes, it sounds like the concept would be a topology class, which I think that has been, without using that name, has been brought up on the mailing list. There were a couple of people who were suggesting that we define CRDs that describe topologies. And that's a whole separate conversation.
Yeah, so those classes could be broken into, like, I don't know, a choice of failure domain A, B, and C is one thing to maybe pursue. An orthogonal one would even be to classify if there are different classes of, let's say, compute resource, some of which are, you know, much better performant or something at high expense versus others. Maybe you could put labels like that too. But I think the key is to get general concepts of desired outcome on these rather than specific mappings that are going to break portability.
And would you, that's a great line of reasoning. Would you expect that even region and zone might fit into that model?
I think so. I mean, the whole concept, a lot of the use cases for both affinity, for anti-affinity are going to be related to failure zones to just achieve redundancy, to have better characteristics in the event of failures. Maybe sometimes you even spread them out because your workloads are coming from all different places, and by hosting these things all over the place, you can have services spread out intentionally so that some secondary thing going on results in better performance. But I don't think we should elect for the specific use cases or the specific clouds in the part that's standardized. We should simply make declarations that maybe we try to identify the classes that would be useful to support and essentially have a lower tier that uses text labels to map them to reality at deployment time.
Yeah, that's super. Also GPUs and Windows nodes, like anything for which there might be taints or tolerations that have.
Yeah, and for some of those like GPUs, one could maybe argue that the support for that kind of stuff's already there, but maybe now that we have CRDs and things, there's a better way to do it than what got put together. But I've been to plenty of talks going back, I think, 2 years on how to support those with the scheduler. So I don't think I don't think the case is there that this is completely unsupported today, but there might be opportunities to make it better.
Yeah, so there's definitely a trade-off with complexity. So I guess, okay, so to move forward with this, I think for folks who haven't read the mailing list thread, I think folks should read that. It's a really long thread, but we touch base on a lot of the things we talked about on how to define topologies and what are the trade-offs. So Stephen and maybe Jago, like, do you guys want to take a read at that mailing list and see and maybe reply and continue discussion there?
Sure. Yeah, I did. I find sometimes those threads tend to meander in a way that's not terribly productive, and coming up with a proposal with that thread as a background might be a out of band more productive use of time. So I am interested in it. I think also the perspectives of the user. I think there's an easy out of saying here's a junk in the trunk place to put whatever you want for your own provider, and that's the easiest thing for any given provider. But it does come at the cost of portability, and so I think keeping those multiple perspectives in mind is important too. But yes, I understand that we're at the end of the useful discussion here. And Stephen, I'd love to keep the conversation going offline, whether in that mailing list or in collaboration of some proposal.
There's a CAP which has a much shorter discussion thread where it might also be useful to jump in there instead of the mailing list.
Yeah,
Okay.
I have to confess, I haven't read through that mailing list, and the only reason I chimed in here is that I have been in years worth of discussion of something very similar to this going down in the storage SIG. So,
And we don't want to do that again.
yeah.
Yeah, but that was my point, is that your perspective there would be useful, because a lot of the discussions are getting blocked on the fact that if we can't validate it based on real use cases, then we shouldn't add it. And so if you had valid use cases to introduce those concepts, then it'd be helpful. Cool. Anything else on this topic that anyone else wants to raise? All right. One second. Let me share my screen. I wanted to go over this, the charter update with you. Can folks see my screen?
Yes.
Okay. So last meeting, Fabio raised a concern around what we're going to do in the community to how we're going to handle sort of like orphan sub-projects that previously belonged to the provider SIGs. And so he proposed a charter update that essentially says any sub-project that is currently owned or would be owned in the future by SIG AWS, SIG Azure, GCP, IBM, OpenStack, and VMware would essentially automatically kind of fold into fall under our SIG, unless there's another SIG that it makes more sense to go there. And so I put a lazy consensus time box for today's meeting for this. So I think for charter updates, I think we should at least vote to see if there are any strong objections to this charter update. So yeah, let's vote. Is there anyone that is opposed to this change? Going once, going twice, 3 times. All right, yay. Okay, so that was it for that. Just wanted to make sure that charter updates are done in front of everyone in the SIG. Yeah, that was it for the agenda. Is there anything else that folks wanted to add? Yeah, Walter.
Sorry, I had to unmute. Just quick informative. The API server network proxy cap was marked as implementable last night. So that should be in 1.15. And we have a Kubernetes SIGs network proxy repo, which is owned by this SIG. We have contributions from a couple of people at GCP and a couple of people at AWS. If other people are interested, please reach out. We already have a prototype of the network proxy, and hopefully soon we'll actually have a prototype of integration with the API server itself.
Awesome. Thanks, Walter. Cool. Any questions on that? Awesome. Anything else that folks want to talk about? All right, then. We'll give everyone 30 minutes back in their day. Thanks, everyone.
Thanks. Take care.